In the previous video, we were trying to create a facies model from the upscaled Willow data. We were basically trying out different algorithms or different methods for creating those models, and then applying those different methods on different layers. And one of the when we were so most of the work is done inside of this faces button, faces dialog box. If we click on it, it's going to give us some indication about what kind of algorithm we're using. Right? We tried a sequential indicator. We tried this sequential indicator simulation thing, and then we were applying this kind of object modeling stochastic to many of the layers. And then for the top layer, we were using for base cretaceous, and to top order, we were using just a assigned value. Right? And for the bottommost layer, for the bottommost zone, that's top eve to NIS 1, it's we were trying to use object modeling stochastic algorithm, and then this adaptive channel, we actually copied the settings from table 1 to table 2 to this top eve to NIS 1 layer zone, right? And then we changed this fraction manually, right? For this particular layer, what we were trying to do is actually to use a surface, to use a probability surface to actually control how the channels are going to be sort of how the adaptive channels are going to be modeled, basically. But we were having some trouble when importing this probability surface. Right, I actually did something wrong when we were importing the probability surface, and we were looking at a probability that's kind of negative from -1 to 0, right? The probability value goes from -1 to 0. That doesn't make any sense, right? The reason is that I imported the data with the wrong template. So now let's delete this data. Let's delete it. Yeah, I want to delete this, and then we're gonna try to re-import it. Import file. Yeah, that was the file that we were using. The file of type zmap plus grid. This part is still correct, right? We click on open, and it's a regular surface, but the template is not elevation depth. In the previous video, I was using elevation depth, and that's completely wrong. It's supposed to be probability. Petrel actually has a template for probability. It's like a way on the bottom. So way on the bottom. Right. It's called probability. Right. It's actually very close to the bottom. It's in the continuous other templates, and then you have probability as a template, right? And then, okay, now we have a channel probability. That's a two-dimensional surface. If we would like to sort of look at this probability, we can click on it. And if we sort of activate this particular surface, we should be able to see the surface tab. And then we can put on the color legend. Now the value range seems to be correct. It goes from 0 to like to 1, right? Okay, so that's supposed to be the surface probability surface we're going to use to actually condition our adaptive channel. And now we can go back to the 3D window, and then we will actually go to the property modeling and then click on faces. Make sure that this is the layer that we're trying to model, up eve to NIS 1, the zone that we're trying to model, and then object modeling stochastic adaptive channel, and then underneath trends, we can select this new object that we just imported, and then use the blue arrow to put it in there. Yeah, that's all we need to do. I think background is still constant. Flat plane settings don't really need to change anything other than. And then settings, yeah, we still give like 20% or something, and then layout section levy, that's something that we copied over from tablet 1 to tablet 2. And then we can just click on OK. And now the simulation is done. And then if we would like to sort of display it, it looks like that. It looks like that. If we want to compare it with our two-dimensional map, for example, right, you can sort of see some of the similarities. For example, you have a higher probability underneath here, and then bifurcates. Probability distribution bifurcates into like two branches or something. You might be able to see similar things, have some kind of thing, and then goes into like two branches. It's not possible. It is very unlikely to actually have a channel distribution that looks exactly like the probability distribution because it's still a stochastic object modeling. So it will try to actually fit the probability surface that you provided. But for example, you still have some channel here, right? That's not a sort of that's not exactly identical to the surface provided by the to the probability surface. But you can use that probability surface as some kind of control, right? And this is just for adaptive channels. So you can specify trends, right, using this kind of box. There was another channel. It's just called add a new channel, right? And then if you click on that, then it's going to add a new fluvial channel. It's not an adaptive channel, it's a fluvial channel. And again, if you click on trends, it allows you to specify not only the horizontal probability distribution thing, but you can also provide something that's called a channel trends. For example, flow lines. If you have flow line data, you can actually point them in here. And then if you have source points, where the sediments is actually coming from, the source points of the sediments, you can put it in there, right? And these kind of options are kind of specific to fluid channels, fluvial channels. It's not inside of the adaptive channel. So if you go to the adaptive channel, you don't see those things. But instead, you have this channel trend, this use channel routing thing. So these two buttons, both of them are for fluid channels, but they have different kinds of settings. Let's get rid of this one, right? And then maybe let's just lock this part of the thing. So now we have fluvial facies property that's populated for the entire model, right? So our entire model should have this fluvial facies property now, right? And once our entire mesh is populated with this property, we may want to examine them, right? Examine this property and see if they indeed make sense. And the easiest way is probably just to use the zone filter and to look at the property for every zone, right? This is base Cretaceous to top tablet, and then if we want to look at the layer right beneath it, you can sort of look at the spatial distribution of those phases by looking at by using the zone filter. Then it's going to display the phases for each of the zone, and we can examine them and make sure that they are indeed sensible. Usually at the beginning of a project, the constraint we have, the data we have, is relatively sparse, right? And at this kind of stage, there are lots of uncertainties. So it's kind of very difficult for us to say for sure if the model generated is indeed correct or not, right? But we can still examine them and then make sure that there's nothing that's kind of too unusual, very unusual. And the zone filter is like one of the things that we can use to examine the model. And there's also another very quick way for us to look at the cross sections or slices through the model, and that's by using the so-called property player. We have this button here called players. If we click on it, then it's going to give us this dialog box. Right? And we have lots of options. Intersection player, that's this button, right? That's this option. And then grid player, right? And then property player. We're going to look at the property player. And then once you selected property player, we have I, J, K, these three directions. These I, J, K directions are exactly the directions where we created the mesh, in which we created mesh. So suppose we want to look at the I direction. So as soon as you clicked on I, then it's going to display this kind of cross-section. Right, that's sort of the I direction when we generate the mesh, generate the pillar grid. Right, that's the I direction. So and then we can just click on these buttons, these two buttons, right? And then this slice, this cross section is gonna sort of move gradually, right? And then this kind of cross section playing is like repeating itself. It's playing a loop basically. Every time it reaches the end of the model, it goes back to the beginning, and then you can stop it if you see anything that's kind of unusual. And then you can also play it backwards, right? So this way, it actually moves back, and then when it's actually playing, you can always pause the playing, right? And then you can move it by hand by using these buttons. And then as you click, this index is going to show the index of this particular eye's intersection. And then if you click on this arrow, it's going to allow you to choose. Suppose I want to go to 51, then it's going to go to 51, 50, I mean 66, right? So you can jump back and forth. And then this is the I direction, right? And then you have J direction. So J direction is kind of along this kind of direction, right? And again, you can play it. You can use the player to move across the model very quickly and try to examine if there's any kind of issues or with the problem or with the model. And then you also have the K direction. The K direction is more like a horizontal kind of a sample or horizontal cross section. So if you would like to play it, so it's going to move from top to bottom. And of course, you can stop it at any moment, right? You can stop the playing at any moment. And for now, we're actually playing the fluvial phases, right? So let me see if I can. Let me close the player for now. And oh, I forgot to actually uncheck the K. So close the K, then close the player. And then let me just make sure that I got all the. Yeah, I think I've got all the zones, I think. So for now, we're just looking at the fluvial phases model. If we click on the fluvial phases model and then go to the grid properties, there's also something that's called a Simbox view. It's called a Simbox view. So if you click on it, it's going to sort of rearrange the model as if there has been no structural changes since the deposition, right? So if you click on the Simbox view, everything is going to flatten out, right? As if the entire structure is kind of a static, right? It hasn't actually gone through any kind of structural changes after deposition. And at this point, you can, for example, look at the K direction. look at k direction, and then play it. And this kind of symbox view can be useful sometimes, right? So let's still turn it off. Let's go back to the normal view. And then if you actually right click on the property that we have created in the settings dialog box, you can look at some of the statistics about the creating model. Right. One of the most useful thing is look at the histograms, right? So what we would like to have is that those three bars, the bars that with three different colors are kind of at about the same height or something, right? So this blue bar is for fluvial's model. That's this three-dimensional model that we have created, right? This is the blue bar, and then the green bar is the upscaled cells. That's the cells penetrated by the wheels, and then this green bar was created after we have done the upscaling, right? So these three buttons controls the display of the models of the columns, and the red bar is for the wheel logs, the original wheel logs we did the upscaling from actually. So it's, and then 0, 1, 2, 3, 4, 5 are just corresponding to background and flat plane channels and levies and crevice splays and channel margin and oxbow legs, that kind of thing. So for background flat plane, the model has 62% of background flat plane, and then the upscale log has 62.3%, and then the original wheel log data actually has 60.3%. So the difference is kind of minimal. It's difference is kind of negligible. But for the second phase, which is channel sand, the model has 23.2% channel sand, and then the upscaled cells has 12.7%, and the original log, the original wheel log data has 13.5%. So this is like a big difference, right? This is not something that we would like to see. And then statistics is going to give you specific numbers, right? For now we haven't actually modeled the permeability and porosity yet. Later on, after we have created models for porosity and permeability, we will be able to actually see the statistical range for those different kinds of properties. But for now, so XYZ fluvial facies, XYZ, this is sort of the spatial extent of our reservoir model. And then fluvial facies goes from 0 to 5 because we have six faces, right? And then this part isn't sort of too meaningful, so not particularly useful, but for this kind of discrete logs, standard deviation variance, these values probably don't really make much sense. But for those permeability or porosity models, those values will make a lot of sense. And then here you can see property upscaled and wheel logs, right? So this is the property of the three-dimensional model, the spatial model, 3D, and this is for upscaled logs, and this is the original wheel logs. So it's basically showing you some statistics about all those three different kinds of properties, right? So those numbers or those are kind of statistics actually gives you a overall idea, a general idea about if there's a big problem with the facies model that we just created. It's actually important for us to actually examine the facies model very thoroughly, because later on when we create the permeability and the porosity models, we're going to use the fluvial facies model as some kind of conditional constraint to that's going to apply some kind of control on the generation algorithm for permeability and porosity. Those are kind of continuous logs, continuous properties, right? And if you would like to look at the details, if you would like to look at the details of the model, there are there are there are there are several ways. There are several ways for us to do that. Um, the first thing that's kind of relatively simple is to actually just so now we have intersections, right? We have intersections. We have grid I direction, grid J direction, that kind of thing, and then general intersection. Let's put on the general intersection, right? So this general intersection was created by just but right click on the intersection and then insert a random line. Right? Once we have activated this general intersection, we have a context-aware intersection tab. If we click on that, it allows us to clip. It allows us to clip, right? Allows us to clip. For now, and then once you apply some clip. So for now, it's a clip behind, right? So suppose we apply clicking front. And then once we have clipped, we can see into this particular model, see an inside cross section that goes through this three-dimensional model. And then we have this button that's called visualize on intersection. We have to sort of enable that. As soon as we clicked on this visualize on intersection, some of the gray boxes are going to become blue, which means that all those properties can be displayed on this particular cross section. So for now, it's bulk volume that's being displayed on this cross section. But that's not exactly something that we are interested in now. We are interested in the fluvial facies model that we have just created. If we click on fluvial facies model, we're going to be able to see that right away on this particular general cross section that's kind of oriented in a strange way. If we want to see the horizons, we can put the horizons onto the general intersection. If we want to see the faults, all the faults are going to be displayed, right? And at this point, we can just click on this button for the manipulate plane, and it's got a keyboard shortcut. That's M, capital M, M, or the M key on the keyboard. And then you can just drag it. You can just drag this intersection or general cross section, and then move it across the model. Move it across the model, and so if you just hold down the left key on your mouse, it's gonna allow you to drag and shift this general intersection through the model. If you hold down the control key while you drag, it's gonna allow you to rotate. So it's gonna allow you to rotate the plane. So you can see see the model from different angles. And this is some kind of quite a quick way for us to actually examine the models from any kind of angle and from any kind of a position, right? This general intersection, which is actually very useful. It's, and it's also quite convenient to use. So if we would like to turn off this kind of visualization on intersection, we can just click on it again. So visualization on intersection is kind of deactivated, and then clip in front. If we deactivate it, then it's going to display the entire model without any kind of clipping. Of course, you can also turn this intersection into like a horizontal intersection. Right? A line horizontally will allow you to turn this intersection into a horizontal thing, and then again you can manipulate the plane and then move it across. Right? But now it's going to give you a horizontal cross section instead of a vertical cross section, and then you can also apply the clip. Right? Clip. That's going to give you this kind of contour line. That's for fixed depths, right? For fixed z-axis, right? So that's still aligned vertically, and then yeah, turn off the clip. It's deactivated. Right. This is again our three-dimensional view. And sometimes we would like to actually see the spatial distribution of the faces with the wheels, right? So suppose we put on the wheels. That's all the wheels for this particular region, right? And we also have a wheel section window, right, on which we are displaying all the logs. Right? And for now, the region that's kind of between the different wheels are filled up with just the solid color. Right? Suppose we would like to actually put the faces, fluvial faces model as the kind of a color field between neighboring wheels. How can we actually do that? Right? And that's also one of the operations people often do. So this is how many wheels? How 3 wheels, right? What about the other cross section? Does it have more wheels? It's also 3 wheels, right? So maybe let's still go back to this wheel section. Okay, so now we have the fluvial faces model, right? If we would like to display the fluvial faces as a model, as a track, we can click on this box, right? Click on this box, and then it's going to be displayed as a track, right? But this track is kind of identical to this particular track because this is actually the upscaled faces log, right? And throughout the model, on our 3-dimensional model, if this is the cells that's kind of penetrated by this particular wheel C3 is going to be identical to the upscaled faces log, and you can sort of see that it's actually indeed identical. These 2 logs are indeed identical. So just displaying this fluvial faces model as a track is probably not so interesting because you already have that. And the histograms, when we actually looked at the histograms of the 3 different kinds of models, the upscaled log, the original wheel log, and the model, the difference between among those histograms are actually quite small, right? Should be quite small. And then if we want to sort of display the model as some kind of background between those different wheels, we can right click on it. And then on the bottom, we have add to global template, right? And then we can either add it to as a vertical track or deviated track or as background, right? And then if we click on background, let me change the vertical scaling to 2000, fix it. And you will be able to actually see the fluvial faces in the background. But for some reason, it's covered by let me go back to the template setting. So we now have a fluvial faces as the background, right? Right, that's the fluvial face, that's the background. And a boho marker plane A, but I still want to see the boho marker symbols and labels. And let's uncheck this show color field at zone level. And this way we can see the phases, the fluvial phases, right, between the wheel logs, right? That's just for displaying the fluvial phases as the background on a wheel section window. But if we actually go back to the three-dimensional window, for every wheel fins, we actually have a cross section, right? We actually have a cross section. So if we click on this cross section, that's C3 to A16, right? We should be able to actually see this this particular wheel fins, right? You can see this particular wheel fins. Let me turn off this property, and maybe turn off the wheels also, so we can see this particular wheel fins. Right, that's C3 to A16. So now let's try to actually display this property on this particular wheel fins. Right. So this kind of cross section is also something that's called an intersection. If we activate it, we're gonna see intersection here. Right. We're gonna see intersection. If we click on intersection, we have this button again called visualize on intersection. Right. We can click on it. So now again, lots of gray boxes become blue boxes, right? And so at this point we can just select the objects we want to display. For example, faults, horizons. So now we see horizons. But faults, we don't see the faults, right? Because maybe let's turn on the wheels also. So it's got some projections of the wheels. And then what about fluvial faces? Now we can sort of see the fluvial faces in 3D, right? And one of the things that people often do is to actually create a cross section, create a cross section window. I mean, intersection window. Right. If you right click on this particular cross intersection, then you have the choice of create a new intersection window. And this new intersection window is gonna go through the three wheels that we have selected, right? So now we have an intersection window 1. And for now, there's nothing displayed except for the wheel trajectory, maybe. But you can display the fluvial faces. It looks like still there's nothing. Let me click on the big eye. So now I can see the fluvial faces, right? And if you want to sort of put on the faults, put on the horizons, then it might give you a better view about it. Let's fit to height maybe. So this might give us a better view. Fit to height is gonna give you this fit to width. Now you can just sort of shift this thing. Zoom in. That's gonna give us this particular view that we are looking at in the three-dimensional window, but it's kind of plotted on a two-dimensional cross-section intersection map, right? Which might be more suitable for obtaining a hard copy and look at this particular cross-section at in a better format. Right? And this kind of display is applicable not just to fluvial facies. Later on, also after we have created the porosity and permeability model, we can also do this kind of display on this particular whale section, right? And when we actually did the general intersection thing, let's turn off the display here. When we did the general intersection, this particular thing, maybe I should uncheck it. When we did this, we can also right click, right? And then it's also going to give us a create intersection window option. If we do that, we should be able to actually create another intersection for that particular general intersection, right? And then we can still display the fluvial facies model onto this particular intersection, and then with the faults and horizons plotted on top of it. And if we have whales, we can also put the whales on it. Looks like some of the whales are too long. Let's do I have a whale? Do I have a whale filter? Right, this way it's gonna give us right. So it's gonna give us another intersection that goes through this particular general intersection, right? If we found a good general intersection to look at, we can just right click and convert it into an intersection window. So we can print out this particular general intersection as a hard copy. Right. And that's another way of examining the cross sections of those properties, right? But let's turn it off. Let's turn it off and go back to look at the three-dimensional model, right? And sometimes we would like to actually examine specific cross sections that may not be a flat line or may not go through the whales, right? In that case, we can try to create a polygon, right? If we draw a polygon through our model, and then we can create a intersection or cross section through that polygon, right? And in this case, we can click on this thing, polygon editing button. It's again inside of the property modeling tab, right? And this button is automatically enabled, right? So let's click on show plane while we're picking. If we want to sort of create a new new polygon, what we have to do is to actually hold down the control and also the shift key, and then we can just start clicking. Oh, so I think I did something wrong. So by default, this is actually a project boundary. That's a polygon that we used previously. So we have to create a new polygon. Let's click on new polygon. Now it's a new polygon, right? Now it's a new polygon. And now now we can hold down the control key and also the shift key, and then start clicking. And then as soon as we got the first point, then it's gonna create a polygons 1 and then polygon line. And at this point, we can just hold down the control key and then keep clicking. And as we click, you can sort of see the plane or the polygon line is actually being created, right? And we can zigzag. We don't really have to sort of follow some kind of straight line. We can sort of use any kind of a shape, right? And once we're done, we can just stop clicking. And by this time, we should be able to actually have this object that's called polygons 1, right? And if we would like to actually create a vertical intersection or vertical plane from this particular polygon, we can just right click. This is called, we have create intersection here. Right, we can click on it. And now we have a vertical intersection, polygon 1. So this vertical intersection was created from this polygon that we have just drawn, right? And then you can sort of see the intersection. That's the blue screen here. And then at this point, we can just turn off the display of the polygon. And then we have a let's change our cursor back to this little hand. Maybe close this palette. We have an intersection that goes through our model, right? Again, we can go back to this. We can click on this thing, click on this vertical intersection, and then we're gonna have this context-aware intersection thing, right? At this point, let's turn off the display of the model, and then click on visualization on intersection, right? And then we can put the horizons on it, put the folds on it, and then put the fluvial faces on it, right? So this gives another way to visualize this three-dimensional property model in this inside of this on this particular view. Oh, why the project polygon is being displayed? But anyway, that's and if we would like to actually create a new intersection window, again we can right click on this particular vertical intersection that we just created by using a polygon, and then click on create intersection window. And again, click on fluvial faces, and then horizons, folds, and then maybe put the wheels on it. Let's fit dynamically, and then see everything, right? So that's going to give us another intersection window for displaying the petrophysical property on a arbitrary intersection, right? That's kind of drawn by ourselves. Let me go through it. Let me just clear the view. And then let me still put back the fluvial faces model. And sometimes we would like to actually look at the spatial distribution of a specific face, for example, right? Suppose we are interested in finding the spatial distribution of only channels n, for example, right? So how can we actually do that? Again, let's click on the property, and then we go to the grid property context menu. And then we have something that's called property filter. It's called property filter, right? And we can click on it. Now we have this filter dialog box, right? So we can click on the use value filter, right? And then we can select the fluvial faces model that we are interested in looking at, and then click on use filter. Suppose we would like to see just the channel's end, right? And then we can just click on channel's end. And if we click on apply, then it's going to show us the channel's end. This is actually the channel's end for all the zones, right? So we may want to look at those channels end for each of the zone individually. Let's turn off zone filter. it's quotated. And then, so this is tarbert 2 to tarbert. That's where the channel end actually is. And then we can look at the next one, tarbert 1 to tarbert 2, right? That's where the channel ends are. And then this is for top nis to tarbert 1. And then nis 1 to top nis. And then this is top eve to nis 1, right? So we can look at just the channel end for each of the different zones. And if we want to turn off this particular filter, just unclick use filter, unclick use value filter, and then apply. And if you would like to sort of see where the oxbow legs are, you can just select oxbow legs and apply the filter. The operation is exactly the same. The sequence of clicks is exactly the same as our example. So let's close this dialog box, right? And that's one of the ways for us to examine a particular face, the spatial distribution of a particular face, right? And another way for us to actually examine the face is by computing more properties from the faces model. Right? For example, if we right-click on properties, right-click on the properties folder name, and then we're going to have something that's called a calculator. We used the calculators before, right? But this time we're going to use it in a different way. We're going to say, let's call it NTG channels end. It's going to equal to NTG channels end. It's going to equal to if the fluvial facies model, click on this fluvial model, equals to for our channel end, it's so this is background flat plane, that's 0. Channel end is 1, right? So if the fluvial facies model equals to 1, then the net pay is going to be 1, right? Otherwise, the net pay is going to be 0. And that's going to be our formula for computing some kind of indicator about the channel's end, right? And then we need to specify a template. Let's just use net pay as our template. Yeah, let's just use net pay as a template. And then at this point, we can just click on enter. Close the dialog box. Now we have something that's called net NTG channels end, right? That's a different kind of property. We can also visualize it. And for now, it's the color range is kind of strange, right? But it's okay. We can adjust it. Let me see if I click on adjust the color table. Oh, it's automatic scale already. Let me see. Legend. So 0 means it's 0 or 1, right? It's either 0 or 1, but it looks like the color difference is like not so big. So let's try to change the color table. Change the color table. Right. Maybe let's change this color to blue. Okay, much better, right? Now we can see the locations of the channel end much more clearly. Right. And this is actually a property that we have computed by using the fluvial facies model and also the calculator, right? This is sort of a secondary property. It's a secondary property that we derived by ourselves. And again, you can examine it, right? Using all the techniques that we have talked about so far to examine the interior of the property, right? To look at the cross sections, to look at the map views, to look at all the kind of different properties, right? And then one of the things that might be useful is to sort of look at, if we right-click on this particular property and go to settings, So this is a three-dimensional model, right? Let's see if we can actually extract some two-dimensional map view plots at different depths for different zones. That's going to give us some indication about where the sands, where the channel sands are. Let's click on operations. Right, operations. And then we have two folders. One is called property operations. The other one is called map from properties. So by default, this folder is kind of expanded. So we can look at the make net maps for each zone, right? So what's going to be the formula for computing the net map, right? It's the property times the height, and then the index I is actually an index for the for every cell. For every cell. So what this thing is gonna do is that for every zone, it's gonna do this kind of calculation and summation, right? The property now we are using is a NTG channel sand, right? It's 0 or 1, right? The value inside of each cell it's either 0 or 1, right? So all the red cells are gonna have a value of 1, and all the blue cells are gonna have a 0 value. So PI is gonna be either 0 or 1, and then for every cell it's got a height. It's got a height, right? And then it's gonna do this kind of multiplication. So for those cells with the sand inside of it, it's 1, right? 1 times the height. But for the cells that's with the without the channel sand inside of it, then it's 0. 0 times height, it's 0, right? So all the cells that's without channel sand will contribute nothing to the summation, right? And the summation is just going to be the cells with the channel sand and then multiply the height of the cell. And then before we click on apply or OK, we must click on run. Otherwise, it's not going to do the calculation, actually. And then we can close this dialog box. So now we got a new folder that's called net maps for NTG channel sand. And then we have one map for every different zone, right? Base cretaceous, top tower, tower 2, top tower, that kind of thing. And at this point, we can go to a two-dimensional window and try to sort of look at. So, oh, its channel probability is still displayed. Maybe let's look at this one. Right. And then, again, we can adjust the color table. Oh, it's automatic scale already. And then put on the color legend. So this is sort of the net map for channel sand of the tower 2 to top tower zone. Right. Gives us some indication where the channel sands are. Right. It's in the red regions. Red regions we have a thickness that's kind of higher too. And then this is for tower 1 to tower 2. Right. Tower 1 to tower 2. So the thickness can reach like 50 meters here. And then this is for top knees to tower 1. Top knees to tower 1. Right. This is for knees 1 to top knees. Knees 1 to top knees. This is the bottom layer, top eave to knees 1. Right. So it shows you where the channel sands are for each of the different layer. So all those capabilities allows us to actually examine the model in different ways and to extract lots of secondary properties and secondary visualizations very quickly, right? We can sort of come up with different kinds of visualizations in just a few clicks. And in the next video, we're going to sort of try to create the models for porosity and permeability by using the fluvial facies model as a control.